discuss to you about triangular number sequence, wherein this is a type of number sequence. So we have here T1 and T2 as the illustration for this topic. For T1, okay, if you're going to draw a dot, first category, of course, we have that one dot. For T2, so this is the first category and the second category. So all in all, it has a 3 dot. What if we were going to find for T3, T4, and T5? So for T3, as part of the illustration, we were going just to draw a dot. This is the first category, second category, and we were going to draw 3 dots for the third category. So we were going now to count those dots. So 1, 2, 3, 4, 5, and 6. So in T3, we have 6 dots. How about for T4? Okay. So it is very hassle for us to draw dots if the given number is big. So let's find for the pattern. So did you notice any pattern here? Yes, which means we are just adding the previous number to the present number. So in T4, it means that is 6, which is the previous, plus the 4 category. So it means there are 10 dots for this. To prove this, let's draw. Second category, fourth category. This is the third category and the fourth category. So we have this 4 dots. So we were going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So that is correct, right? How about for T5? So we were going to use again the previous. So 10 plus the present, which is 5 category. So there are 15 dots for T5. Okay, so that's the given pattern. I will explain to you about explicit form of a sequence. An explicit form of a sequence is a sequence that can be formed in which a preceding term is not necessary to find the succeeding term. We have here the example, sequence 5, 8, 11, 14, and we were going to determine the next 2 sequence of the given example. Then we were going to find for the explicit form of this sequence. So this sequence can be represented as A1, A2, A3, and A4. So A1 can be represented as is equal to 5 and represented by this is the combination of 3, or let's say n is equal to 1, 2, 3, and 4. So the n number here, say 1. Okay, to make it 5, 3 times 1, to make it 5, we need 2 there. So A2 is equal to 8. Then the 2 here is the n. Then we were going to write 3. So it is 6. Then we were going to add 2 to make it 8. So 8, 3 is equal to 11. So 3, what will be going to multiply? 3 also, it will become 9. Then add 2 to make it 11. Then A4 equal to 14. So times 4. and 3 times 4 plus 2 to make it 14. Now, for this given a representation, we conclude that we have that 3. We are multiplying 3 by the different n here. This is the number of the sequence, term of sequence. So then n for the unknown term of sequence. Then we are adding 2 for the constant. So this is now our explicit form of sequence. We can write as an for the unknown, the sequence unknown equal to 3n plus 2. Okay. So we are determining for the next two sequence, right? So we were going to use this now for the other sequence. Okay. So we are going to find for 5th and 6th. So if n is equal to 5, okay, so a5 for the sequence 5 equal to 3 times 5 plus 2. So a5 is equal to, so 3 times 5, 15 plus 2, that is 17. So that is for this sequence number 5. How about for 6th sequence? So if n is equal to 6, a6 is equal to 3 times 6 plus 2. So a6 now is equal to 3 times 6, that is 18, plus 2, that is 20. Okay, so that is for the first example. But then there is also another way in doing this. How? Okay, I will present to you another way in doing the explicit form of sequence. First thing is, let's find for the difference of the sequence. So the difference of 8 to 5 is 3, 11 and 8 is 3, 14 and 11 is 3. So this is now the common. So we can write as, so I will write it here, an for the unknown, automatic. Then the common is 3 multiplied by the number of term. Then let's say, okay, we were going to get the first 5. Then let's subtract the 3 times, let's say n is equal to 1 for the first. This is the first sequence, right? Then this 1 equal to 5 minus 3 times 1, that is 2. So it means we are just adding 2 to every sequence. So we derive now an equal to 3n plus 2. That is for the explicit form of sequence. Now, as stated here, we're going to determine the next two sequence. So, ganun pa rin yung gagawin natin. We're going to use the formula for the next two. So the 5th, that is a5 equal to 3 times 5 plus 2, still 17. And for the other is, I will just write it here, a6, wherein n is equal to 6, equal to 3 times 6 plus 2, that is 20. That is same as the first. Here another example of sequence, which is 2, 4, 8, and 16. And we were going to determine the next two sequence of this given example. So in this given example, we were going also to find for the pattern formula so that it is easy for us to solve for the next two sequence. So the first thing to do is to write for the sequence, and we were going to get the difference. This is 2, 4, 8. This is 2, 4, and this is 2. So the last difference is 2, so it means we were going to use that as the base. And If this is the case, as you observe from the given sequence, it is being doubled, so it means there is exponential happening in here. So let's say this is raised to n. This is now the formula, and we were going to check if this is really the formula, the authenticity. So we were going to predict as n is equal to 1, 2, 3, and 4 as the representation of this given sequence. Then let's now use the formula. So let's say a1 is equal to 2 raised to 1, so that is 2. a2 equal to 2 raised to 2, that is 4. The a3, that is 2 raised to 3, that is 8. And the a4 equal to 2 raised to 4, that is 16, which is correct with the given sequence in here. So it means that this formula is authentic. This is the real pattern. Okay, so we were now going to determine the next two sequence. So we were going to find for the fifth. So it means that is 2 raised to 5, that is 32. So a raised to 6 equal to 2 raised to 6. So 32 times 2, that is 64.